So, Surds, and then I've got my little here for nerds, just because it rhymes, but also I think it's a higher topic, so it seems to work quite well. So the things you need to know for Surds are these 6 rules. They look kind of complicated with A's and B's in, and then when you put numbers in and see examples, it's so much easier. And then I've also got a little way to remember them, which I'll tell you after I've gone through exactly what these mean. So first rule, this one I call multiply, for obvious reasons. We've got a root multiplied by a root, which means you can just root the whole thing and multiply the things inside. When we look at numbers, that makes it so much clearer. So let's say I have root 5, root 3, so A is 5, B is 3. We can just go root, multiply just the A and B together, 5 times 3, root 15. That's all that means. If you have 2 different roots multiplied together, you can just multiply the numbers but stick them under one big root. So that's the multiply rule. This is also a good way to see when we have root something squared, that you just get that something back, even though you can think of it as kind of undoing, because squared is the opposite, it's square root. If we think about that, that is root A squared is root A multiplied by itself, root A, which if we're using this rule is root, you can just multiply those together, AA, which is root A squared, which is A. Ta-da! Okay, I'm just going to get rid of that, it's just a nice thing to see. Next rule, this one I call divide, surprise, surprise. Very similar to the multiply, but it's the fact that if you have 2 things divided, you just divide them a bit, stick a bigger root on top. Example with numbers, root 6 divided by root 3 equals, you can do one big root and just do the numbers, 6 over 3. These are quite nice really. So 6 divided by 3 is 2, so root 2. Third rule I call add, and this is the warning rule where you do nothing. So if I have root A plus root B, I can't actually do anything with that because they're completely different things. That's like having X plus Y. You can't add them together, or it's like having apples plus oranges. You can't add them together because they're just 2 different things. If I had roots that were the same, so like root 2 plus root 2, in that case I have 2 root 2 because these 2 are the same, but in this example they're different. So this example is saying root 2 plus root 3. I can't do anything to do that. They're completely different, which is quite nice because it means you don't have to do anything. We like that rule, doing nothing. This one I call the squaring one, number 4. I don't like this rule, I think it's a bit pointless because if this was me, so apparently, I'm not even going to do an example of that. Apparently if you have this, it goes to that. But the way I would do it is I would literally just, right, so we've got A plus root B squared. So that's that times itself. So we've got, I would just write it like that and then do FOIL. So I do first, outsides, the insides, and the last in each bracket. So if that was me, I'd completely ignore that rule and I would just write that as 2 brackets and square them. You can remember that if you want, but like, do the maths, you know? Rule 5, this one I call brackets because I don't really know what else to call it. And that, I don't know if you remember in the factorising video, but difference of 2 squares was A squared minus B squared equals A plus B, A minus B. And we also did an example in that video where we had something, was it P squared minus 3? And because this wasn't squared, but we could take B as root 3. So that's exactly what is happening in here, but the other way. So hopefully you can kind of see that. If not, again, don't worry. It's literally kind of like 4. If that was me, I wouldn't even bother remembering this rule. I would just expand it every time. Okay, this one I call denominator. This one is rationalizing the denominator. So we don't like roots on the bottom. We want to get rid of them. And the way we get rid of them is by multiplying by the same root but on top and bottom, because we know if we want to rationalize this denominator, if we have root b, we know if we multiply it by another root b, that is root b squared, and we know that that just gives us b, which doesn't have a root, which is what we're after. So we know if we times the bottom by the same root, we're going to get something that isn't a root. And we know in fractions we have to do the same to the bottom as to the top. So that's why we multiply it by this term here. Important thing to note is if you have something that looks like this, a plus or minus root b on the bottom, will either be plus or either be minus, you multiply it by, on top and on bottom, the same thing, but you change the sign. So if it has a plus there, I multiply it by a minus root b. But if it had a minus there, I multiply it by a plus root b. And we're going to see an example of that next. So when I actually look at these rules, the only real thing to remember is multiplying one, the dividing one. Adding one, you do nothing, but that should kind of be obvious anyway. These two, I'd kind of ignore learning. What's the point? Just if you know how to expand the bracket, just do that anyway. So we've got multiplying, dividing, and rationalising really. So if you've got a root on the bottom, you want to get rid of it by multiplying by the same root, or when it's a bit more complicated, changing the sign. So the way I remember each of these 6 rules, if you do want to know all 6, is bad DMs. So B, that's the bracket one. So I think the best thing to do with practicing these is just go straight on to exam questions and just practice. Write root 50 in the form k root 2. So what we have to do here is we know we're looking for a root 2. So I'm going to look at root 50 and I'm going to think about that multiplying rule. So what is 50? Bearing in mind we're trying to find a 2. So I'm going to do 2 times something, and 50 is 2 times 25, and we know from our multiplication rule that this big root can be separated into 2 smaller roots. So I'm going to put the 25 first, so root 25 times root 2. So we can just take the big root and split it into 2 smaller ones. And we know that root 25 is just 5 times root 2, and we know that we can write this as, you can just get rid of that multiplication here. So that means k is 5. So we know we've done it right because we've got something in that form, and I knew to pull a 2 out from the question. So this is the next one, very similar. Write 7 root 20 in the form k root 5. So I'm just going to leave the 7 here. Right, we'll write 7 root 20. So 7 times, and then we've got root 20. Trying to split that up, make it look like something different. And I know I've got a 5 here. So I'm going to do something times 5, and the reason I chose that is from the question, basically told me to do that. And then 20 is what times 5? 4 times 5. And we know from our rules, I'm just ignoring the 7 for now, we're just keeping it there, that this big root can be split into the 2 smaller roots. It's the same thing. And we know that root 4 is just 2. And we know we can just multiply numbers together. 7 times 2 is 14. And we also know, just like before, that we don't actually have to write that big times there. And now, there we go. That is very similar, same form as that. So we know we've done. That's how you do those questions. So you need to look what's under the root, turn it into a big root with whatever number is there, and then just work your way down. Okay, so this question, a bit similar to before. Write 3 minus root 2 squared in the form a plus b root 2, where a and b, this notation is where a and b are integers because I CBA to write out the word integer. So I just don't really care about what it's telling me here. Like, I'm just going to do what I'd normally do and then hope that my answer does look like that, which it should. I look at this and I know I need to simplify it down, and it's squared, so it's that times itself. Foil for my double bracket. First one in this bracket times first one in that bracket, 3 times 9. The outside got outsides. These are the outside points. That is minus 3 root 2. The inside points are these two on the inside. And that is 3 root 2. And then my 2, last one in this bracket, last one in this bracket. Minus minus makes a plus. Root 2 times root 2 is 2. Minus 3 root 2. Minus 3 root 2. 9 plus 2. I like the 9 plus 2. What is 9 plus 2? 11. Then we've got minus 3 root 2, minus 3 root 2. So let's just think of that as minus 3 apples, minus 3 apples. So I'd have minus 6 apples, but they're not apples, they're root 2's. And 11 and 6 are both integers because they're both on our number line with stuff in the middle. So that's how you do that one. So for me, I just kind of ignore the form part until the end when I then check my answer and be like, is it in that form? Yes, looks like I've done the right thing. Next one is rationalise x over root x. This is your denominator rule. So we don't like roots on the bottom. We know that. So what do? We multiply it by itself. But then because we've done that, we have to do the same to the top because fractions. Okay, let's work this out. X times root x, that's a bit like, that's kind of saying, so if I had 3 times root x, I'd have 3 root x. But instead of 3, we've got x. So that could be a bit confusing. So we've got x root x over, and then we've got this thing again. So we've got root x times root x, that's root multiplying rule x times x, which is root x squared, which these go is x. So the whole point is when you have 2 roots, you just kind of get rid of it and take the thing. Not done, just like numbers, something on the top, same as something on the bottom. You can get rid of those. So our answer is just root x for that one. Okay, so we want to simplify 3 plus root 6 over root 3. And again, I'm looking at this, I'm thinking surds because all the roots involved, and it's the denominator rule because we need to rationalise the denominator. Don't like having these on the bottom. So now I have to multiply it by, I look at the bottom, that tells me what I need to multiply it by. And because I've done that on the bottom, because fractions, I have to do it on the top. And we know, again, if you have root 3 squared, which is what we have here, root 3 times root 3, we know that just gives us 3. Again, work through the steps if you want, that's fine. Let's expand the top bit. So this is our single bracket example. Our single root 3 is going to go speed dating, so root 3 times 3. He's also going to want to speed date this guy, and, ooh, I like this bit, so we've got the plus. Then we've got root 3 times root 6, so root 3 times root 6. And we know from the multiplication rule that is root 3 times 6. So you can just do the numbers in a big root, which is root 18. Now, some people might think we're done. We are not done. This, I know, is kind of as simple as it goes because I know root 3 doesn't really go into the thing. I want to look at this. I don't really deal with root 18 much. Maybe this can get smaller. I don't really know. And then we're looking at this root 18. Now, what numbers go into 18? So 1 and 18, 2 times 9, 3 times 6, 4 times nothing, 5 times nothing, 6 times 3, there's our repeat. Okay, so the numbers that go, I'm sorry, I'm doing this so messily. The numbers that go into 18 are 1, 18, 2, 9, 3, and 6. But bearing in mind I'm getting these into roots and I want to get it into a root smaller than root 18, I want to find square numbers, and that is 9. I can rewrite root 18 as plus root 2 times 9. Okay, but this bit here can then be rewritten as root 2 multiplied by root 9. And because I chose the 9, which was a square number, which I did on purpose, I can then do root 2, and root 9 is just 3, which you can rewrite as 3 root 2. So that, bingo, was exactly what I was looking for, and the step that most people would miss and what makes this question hard. And as we can see, there's 3 in all the terms, so those cancel with those. Root 3 plus root 2 is your answer. Also, if you do just type it into a calculator, so if you just put, you can't really see the screen, but if you just put root 18 on the calculator, if it is a calculator paper, then it just gives you the answer straight away, 3 root 2. But if you don't have a calculator, that's the way to do it. Right, so final exam question example here, and this one is a bit tricky. So it says show that 1 over root 2 plus root 2 is this. So the nice thing is it has given you the answer, so you can kind of, you've got something to work towards. So first of all, I want to ignore the 1 over, like I'm just going to look at this part and then deal with the fact it's 1 over afterwards. This root 2 is, I'm just going to make them both fractions, then we're just working with fractions, is that's the same as root 2 over 1, because if you look at numbers, so 3 as a fraction is 3 over 1. So root 2 as a fraction is, so root 3 as a fraction is root 3 over 1. 2 as a fraction is 2 over 1. So because I'm now looking at two fractions that I want to add, and I know that when you have to add fractions, you do a cross and a smile. I could do a cross and a smile, but I just can't be bothered to do that all that faffing around. So I'm not going to do a cross and a smile. So I've got 1 here, I'm going to make that into a root 2. This one stays the same. And then this one I want to make into a root, I want the bottom as a root 2. So I'm going to multiply it by root 2. And because I multiplied by root 2 on the bottom, I have to multiply by root 2 on the top. So normally we're trying to work the other way and not get this root on the bottom, but this time we are. So let's look at this. Root 2 times root 2 is root 2 squared, which is just 2. And then 1 times root 2 is just root 2. Okay, this is just like a perfect adding example question. So same thing on the bottom, we can just add the top. That is 3 over root 2. Okay, so that is that part here, and I'm thinking, oh, that's very similar to the answer, and then I almost forgot, but then I realised it's 1 over. Wait, another way of writing, you could know that is just the thing upside down, but another way to do that is 1 divided by 3 over root 2. And we know when we divide fractions, this is kind of fraction answered, where we know if we divide fractions, we just multiply them, we have to turn it around, upside down, so we multiply it upside down. 1 times that, 1 times anything is just that thing itself, and now we have the answer.